I'll go over one more time because so for the midterm exam we will have 5 problems and just capture the problem, not that. And we will have 5 problems and they will be similar to the ones that I'm showing. The first problem is MapReduce. Compute the total communication between the mappers and reducers, which means the total number of key value pairs that are sent to the reducers from the mappers for each of the following problems. And assume we're using no combiner. So the first problem was word count for data set of total size D, where D is the number of words, total number of words in that file. The number of distinct words is W. And so we mentioned that we are not using a combiner. So when we're doing the MapReduce, each mapper was counting the number of times a particular word occurred and the count of 1. If we can use a combiner, it might increase those counts before sending them to the reducers. And the reducers will then take the counts and produce the final result. So since there's no combiner, the number of distinct words doesn't matter, and the answer to this is D, which means we will have as many key value pairs as the number of words that we have in our document. The next problem is, okay, so for problem 1, the first question was a word count. The second question is for matrix multiplication. So we talked about MapReduce doing matrix multiplication. So the question is, we have 2 matrices. Two matrices. One is size IJ, and the other size JK. So we want to do MapReduce. We want to have MapReduce compute the multiplication of these 2 matrices in one step. Each reducer computing the value of a single pair pair AB, where AB is A is the first element in the first matrix, and B is the first element in the second matrix. So what we need to do here, we have 2 matrices. One is of size IJ, the other one is of size JK. We need to multiply each element with each element. The element is AB in this case. So we're asking, what is the total number of key value pairs that the mappers will send to the reducers in order to do this computation? So what we need to do, we send each item in the first matrix to all k corresponding to the second matrix. So we will take the i's and send them to all the k's. And each item in the second matrix then to all the i's in the first matrix. So if we are to do something like that, then we will multiply I times j, that's the number of elements in the first matrix, and we will multiply it by k, because each item in the first matrix to all the k in the second matrix, so we will get I times j times k. But then we are doing this one more time because each item in second matrix to all the i's in the first matrix. So this is going to be 2 times. 2 times I times j times k. That's the number of key value pairs that will be sent from the mappers to the reducers. And the part C for this first problem is 6 points. Cross product of 2 sets. The first set is A of size A. The next set is B of size B. Now, for these sizes, B is less than A, which means the size B, the set B is smaller than set A. Each reducer handles all the items in the cross product. Corresponding to a single item in A. So let's say, just to give an example, we have two sets. Set A is equal to 1, 2, and set B is equal to AB. We want to compute the cross product, which means we will multiply each element from the first set with each element from the second set. So we will multiply each with each. So the cross product is first with 1 from the first set. First element is A from the second set. So the first cross product is 1A. Next we have 1 with B, each with each. Next we have 2 with A, and next we have 2 with B. That's the cross product of these two sets. And we said each reducer handles all items in a single set. So there will be one reducer here. So there will be one reducer handling this. And there will be second reducer handling this. So again, the question is, what is the total number of key value pairs that are sent from the mappers to the reducers? And in this case, what do you think is the total number? So the answer is, well, the number of elements in the first set is 2. Number of elements in the second set is 2, so these have to be multiplied. Number of elements in the first set is A, size. Number of elements is B in the second set. And then plus the number of elements in A. So this is the first problem.